So, dear ladies and gentlemen, we are continuing. And now let us think about the following. AI nowadays is applied not only for business projects, but also for HR analytics. During the next 30 minutes, Chief Data Scientist HR Yevgeny Grigoriev at Sberbank will share his own experience on development and introduction of HR block AI processes. And during the workshop, you will learn which matrices help improve all the processes in the bank and what is the potential effect of this method and how it accelerates processes. So please welcome Yevgeny Grigoriev. Good afternoon, colleagues. My name is Yevgeny Grigoriev. I am CDS at HR Blog. I'm responsible for introduction of AI in all HR-related processes at Sberbank. Let us begin by explaining what Sber looks like right now. We all know that Sber is very successful, that it's presented in all regions of the country and abroad as well. And first of all, we know that Sber is a bank, but it's not true exactly. Because Sber is a high-tech business nowadays. It's engaged in development of different products and projects, and it's a group of companies, actually, that's united into one ecosystem. So what brings these businesses together? We work on some innovative projects, necessarily, of course. Actually, there's something else that unites us. It's processes. For instance, HR processes bring us together. We have employees in every business. I'm going to be sharing experience that we have applied in our businesses, some initiatives and projects within HR, and it's applicable, perfectly applicable for other businesses as well. Throughout the whole life cycle of employee with a business, you are going through standardized stages in a business. First, you are selecting candidates, then in onboarding of candidates, then people are getting promoted or switching positions, and then the people leave businesses. Inevitably, it happens. In order to be efficient with the resources that we have in our businesses, we need to create tools to help employees to optimize their processes. And at every stage of processes that I have just described, HR-related processes, we have intellectual or smart assistants that help us. On the slide, you can see a number of areas and processes that we're working on. First of all, it's quite large. It's tasks related to recommendation systems. Clearly, we have some employees who come to us, and we see that the market is changes, for instance, and requirements to this job is changing as well. And we need to train our people. This is why we have personalized recommendation systems to train employees. It's not just one recommendation system, but we have a whole block, a whole bunch of recommendation systems that are working together to make sure that training of employees is as personalized as possible. We have a special model that is a dispatcher of training. We have it because we have a lot of sources. We have external sources of catalogs of trainings that are available to Sber employees. We also have Sberbank University that has been recognized the best corporate university a number of times, and it develops its own programs. We have online courses. All this database is analyzed, and based on user activity on our internal platform, we build some recommendation systems and recommendations of services, and it personalizes trainings for people. We have recommendation systems for in relation to vacancies that we recommend to our employees, because people are growing within the business. They are getting promoted, and there might be some requirements to the next level job, and we recommend those to employees. We recommend trainings for our employees to get promoted sooner, and we make a relevant selection of courses that will be relevant for every employee. Moreover, we have recommendation systems that relate not to vacancies, but to a system of jobs, to a system of titles. For instance, for mass specialties. For instance, you're a salesperson and you would like to get a promoted and you would like to become a lead salesperson, lead sales expert. And the algorithm is determining that you're almost ready, and it recommends trainings to you. Next, tasks to recognize information recognition. When people are just entering our ecosystem, then anyway they're providing some information. You're providing your resume, you're providing your CV. And during recruiting, our recruiting people have to process it. In the past, people would have to type in your personal data by hand into our templates, your name, your second name, your date of birth, your certificates, your education, your experience, so on and so forth. But now we have developed a complex of algorithms that automatically analyze it on your CVs, and they put it into our database automatically without typing it in manually. Also, document recognition. At some point, all of us had an experience of joining different companies and becoming employees of different companies. And we have a package of documents that we have to provide to employer. Our passport or our taxpayer number, some other documents. All these documents must be stored in a database. And we have a complex of models that help recognize information after scanning these documents. And they automatically put this information into our database. It saves a lot of time of recruiting people who would have to type it in manually in the past, but they don't do it now. Also, we have tasks related to behavioral prediction of employees' behavior. At the concluding stage of the life cycle of employees with us, at some point people leave the business. We analyze behavior employees. And we know that it's very costly to recruit people, to search, to screen for vacancies, and to recruit new people to our business. But we have to do it from time to time. And people sometimes leave our business, leave some divisions. And our job as an employer is to retain people, to help people develop themselves, to develop their skills within our business. So we need to predict what's the probability that this or that person is willing to leave our business. And we're offering them some more opportunities. And we have the quality model of outflow. For instance, this person is prone to leave in our business, so he's about to leave. We need to take some measures. We need to do something to retain this person with us, and other people are not willing to leave. We have not just qualitative, but also quantitative employees outflow models when we need to predict the personnel outflow rate in a certain time. There are some models that are based on, for instance, neural networks. They work like a black box. There is the data is fed there, the model is processing them, and there is outflowing data. And this algorithm is difficult to manipulate. It's really like a black box. You cannot manipulate it. You cannot impact the process. There are our managers, and we need to monitor the life cycle of our employees with the business to monitor why people might leave or not. And it has been tested with the help of this. It has been taken with the help of this behavioral tracing. Then, time series models. For instance, we predict the sufficiency of recruitment funnel. For instance, we have a sales department, and we have a lot of subdivisions in sales department. We usually call them just bank branches. We have more than 1,000 cities where Sber is present. And we need to understand what is the recruitment plan in order to cover the need of, for instance, this city with these employees. And we do time series models, and we analyze the market in order to do so. We also need to monitor internal movement of our personnel. It's better to retain people rather than letting them go, obviously, but also we need to monitor the way people are rotating within our business. We call it internal outflow, when people are rotating within our business. Also, we work with NLP, natural language processing, and And voice assistants, this is what we do as well. We have a whole set of tasks here. Sber, being an ecosystem, an enormous ecosystem actually, we have a lot of internal platforms. We work with information retrieval. When you need to find information, you need to create an analog of Google, but that will work within your business. That's quite huge. We do classification of information based on text. We need to determine. So the business has some goals. Every employee within the business has his own goals that are a result of the big goal that's broken down for every employee. We have models that analyze this information about the quality of goal setting for employees, so that employees can adjust their goals in case if we see that it's not in line with the goals of the business, or if the goal is not clarified enough and it needs to be adjusted. Also, there are a lot of standard button-based interfaces or smartphone interfaces. They're getting quite outdated. We're working on state-of-the-art technologies. On voice assistants, we have a virtual assistant. Virtual assistant aggregates a lot of functions. You can have a vacation, or you can clarify or approve your leave. Approve your vacation based on this voice recognition system. Let's move on. I wanted to tell you now about another area. It's resume parser, CVs parser. Now we will discuss how a potential candidate becomes a part of our business. A potential candidate gives some information to us about himself. Recruiting employees aggregate information from CVs and they put it into a database. In order to put this information into database manually, it takes about 5 or 6 minutes. But we have created a set of models. It's a complex software that helps automatically recognize data from the CV and put it into our database. Let's discuss this project. Why do we do it? Why implement a project like this? It's easier to work with structured information. It's easier to search for candidates when the information is structured. It's easier to range candidates this way. We can range we can search for more successful candidates among all the potential candidates in the market. We can search for recommendations for different jobs. We see that this candidate is not good for this job, but maybe we can recommend another job for this candidate. We have recommendations of jobs for candidates. We also can find some problem areas in the CV. For instance, this candidate doesn't have enough experience for this vacancy, for this job. We make a record of it and we analyze it, and automatically we can forward him to another job. Or maybe we can get in touch with this person and we can clarify additional information. Maybe he can provide it. Now let's discuss methods of implementation of this algorithm, CVs parting. We have looked into the market and we understand now that in the market, in Russia, in the market of candidates, we have well-known templates and formats that search for candidates. For instance, Headhunter template of CVs. We see it, this template in PDF, and we can analyze this information. So it makes sense to have some standard CV layouts in implementations. We also looked at overall number of types of files, and we see that the majority of CVs that we receive from candidates are PDF. So it makes sense to focus on PDF format because the other formats they account for less than 1%. What the model looks like. First of all, at the first stage, we need to extract information from PDF file. Why does it seem to be that simple? But actually, it's not that simple. If you look at the market, Then there are CVs that are in line with the layout of Headhunter and some custom CVs. When potential candidates create their CVs in any editable format themselves. Some CVs are full text. Sometimes there are 2 columns. Sometimes they have a photo in the CV on the left, on the right, or in the middle. When algorithm reads information from PDF file, it's very simple. He goes from top to bottom, from left to right. When there is a picture in the middle of the file, then it might give you the right information as a result. This is why recognizing text from CVs in 2 columns or 1 column is not that simple. Then we developed a separate model that determines the class of a CV. Either it's a well-known template, a well-known layout, or in a custom CV. After we determine it, we will work with basic categories, and there are different categories. There is information, for instance, name, second name, date of birth. There's information related to his experience of work. There's information related to his education. After that, we process this basic information. I will elaborate on that a little bit later. After we process this information, this basic information, we generate a response in the shape of a file, JSON file. So basic steps. First, we extract text from a file, and we determine whether it's a custom CV or structured CV. Then we allocate it into blocks, either personal information, personal data, education, work experience, so on and so forth. Inside each basic category, we extract specific information with mini parsers. And after that, we collect the responses into a single JSON file. Thus, we get a modular architecture. It's easy to maintain it in case if some formats change in the market. We will track it down easily and we will adjust it. And thanks to the fact that we know what block this information belongs to, that we will use our technical resources optimally. We will have a great speed of data processing compared to a situation if we had only one basic model that would recognize all the text, extract all the text, and would try to parse it all regardless of the block of information. What tasks we are solving this way? Once again, let me repeat, it was a very comprehensive, complex model, and these were different models, and we linked them together into one big composition. We needed to classify documents type, structured CVs and custom CVs that are not done in line with any template, well-known template. Then segmentation of the text into categories, basic information, education, work experience. Then named entity recognition, named entities such as dates, names of organizations, names of companies and businesses the person will work for. But in order to extract these named entities, it's not the most difficult thing to do. The most difficult thing is to define a named entity linking. For instance, this date relates to this, for instance, place of employment, or this business, or this job relates to this place of employment, not to the other place of employment, when we need to put them together into one block. Now let's discuss methodology. In order to assess the quality of work, we have had 305 resumes in hand format, and we had 159 resumes in custom format. Due to some restrictions or limitations, we used markup, obviously. We did it with the help of assessors who helped us do that. And we got marked up text. There were some difficulties that's related to categories such as work experience. For instance, you might say Sberbank as a place of employment, as a work of experience. Or maybe another marker would not select PAO Sberbank. So full name was Sberbank LLC or JSC or something like that. He put Sberbank only without JSC or without LLC in the beginning. Because of these discrepancies, it was very difficult in the beginning to split it into basic categories. In order to assess the quality of these models, we used two matrices. The first metric is accuracy. When in order to interpret the fields accurately, you need to see whether they match or not. For instance, date of birth, or last name, or first name. But we have these fields. We have these fields that don't have well understood interpretation. They can be interpreted ambiguously, and in order to do that, we use another matrix. It's intersection over union. When you look at intersection of how assessors mark it up, either LLC Sberbank or just Sberbank or Sberbank something else, just in order to understand this intersection level, and we use intersection over union. Is used as a quality metric for many. Now let's have a look at the results. Here you can see two diagrams, the left-handed diagram, right-handed diagram. Let's have a look at the left-handed diagram. We had assessors, we had a few of them, and they did markup. And there was no consistency in all fields. And we selected some reference values from the volume of data that I just talked about. We checked it, they're correct, they were filled in correctly, and average assessor was compared to reference parser. This is blue color. Green color is our algorithm compared to the quality of assessor work. And we can see that here we have a few blocks. Do we have a chance to take away this table from the bottom so that I can see it? Yes, thank you. We have a few blocks of information. The first block of information is basic categories such as name, last name, email, region, phone number. There is another category here as well. I cannot see it right now, but it's something like workplaces. We see this information and we see that our algorithm composition is worse at detecting this information. It's poor performing compared to average assessor. We have the third category as well as the third column. It's education. And we can see that at some points our algorithm is even better performing compared to an average assessor. And the last field is all text, all text that is represented in the CV, and that is reflected there. We can see that in the first basic category, basic information, in the first category, our algorithm is performing as well as assessor does, as the marker does. But in some other categories, assessors are working better. This is for structured CV, headhunter, for instance, layout. This was the first case. Now let's have a look at the custom CV layout. People are being quite creative in making their CVs, custom CVs. In some cases, people are even putting their name and second name in different calligraphies, or they change the size of letters even within their name. So for custom CV layouts, basic category is recognized quite well. Second category, work experience, it's lower. In education, parser is lagging behind from assessor, and all text more or less the same in terms of the level of quality. Now, let's have a look at example of algorithm based on synthetic data. Let's take a case, let's take an example. It has no relation to reality at all. It is not representing any real user data, but it will just demonstrate what we have. Let's imagine we have an employee, a potential candidate, Skvartsov Sergey. He's not the real person. I'm saying that this example is very complex. On the top, you can see that we have a number, but it's not a mobile number. It's +7800. It's an overall number. It's not the personal cell phone number. So we need the algorithm to understand that this is a cell phone. This is the phone number of employee, but it's not the phone number of one of the businesses he worked for. Also, we see that the name of the candidate is Skvartsov Sergey, but his email is ivanov.alexander@yandex.ru. Moreover, if you look at the last field, some old text, then his manager, one of his managers was Alexander Ivanov. So algorithm is supposed to understand that Skvortsov Sergei is first name and second name of the candidate, but Ivanov Alexander is, it does not relate to the candidate's name or second name, but email of the candidate is the right one, and Ivanov.Alexander is the right email for this person. Why can we say that we can use some lists, top 500 of universities of the country? It doesn't help. In this university, we have Moscow Technical University of Physics and Informatics and a Department of Fantasizing, Applied Fantasizing. Of course, it doesn't exist in real life, but the model is supposed to understand that this is the specialty and of our candidate. Also, experience of work, test leader of digital transformation. It's a non-existent job, but we're putting it here and we're making sure, we're just checking whether the algorithm will detect it. Another place of employment, Steklanit business, and in the beginning you see some information that characterizes his employment in this business, and then the job is called freelancer, which is not existent for this business as well. Let me repeat once again, it's synthetic data. These are not real data. It has no relation to any real person. So this information was recognized correctly: salary, desired salary, and experience of work, and email, and cell phone number, and second name. It all was recognized correctly. Now let's have a look at the next information that relates to his work experience. If you take a closer look, you will see that dates when the person began and finished working with employers, they are right. The jobs are indicated right, so the algorithm recognized everything correctly. Now let's have a look at the next slide, and here you can see information about his education. And we can notice here that names of universities are put here correctly: Moscow Technical University of Connection and of Communication Informatics. Then department with the university, we call it Fantasizing department. It's non-existent in the university, obviously, but we put it here just for the machine to recognize it, just to test it. Also, we can have a look at the comparison of places of employment. We can, as I made an example, you can state just Sberbank, you can state Sber, and you can state LLC Sberbank, and algorithm must understand that this is the same organization. And final slide related to work experience. I wanted to talk about skills, actually, not the experience, but skills. Here you can see that Russian language is a native language, and he's the feature that he possesses, he's responsible, he says. So in conclusion of my presentation, I wanted to say one thing. People are the main asset, and talented people are shaping the future. Thank you for your attention, and all the best. Thank you very much, Eugenie. And by the way, we have questions. This is why I wanted to invite you back on stage so that you could comment on the questions that you're being asked. Once again, wanted to say that we have a chance to ask questions. In order to do so, please scan the QR code in the bottom of the screen. Many of you have already done that. Just take your smartphone, scan the QR code that you can see in the bottom of the screen. Follow the link, enter the platform, and ask questions to our speakers. Right now, Evgeny Grigoriev is ready to answer your questions. We have a few of them. Question number one. In the presentations of previous speakers, it was said that they were using markers to collect data to train the algorithm to recognize documents. When you are recognizing CVs, how did you collect the data? As I said in the beginning of my presentation, we had some information that was recognized in the shape of text, and then we would forward this text to markers. with the help of people who were doing markers, we would split named entities into different blocks. And we would train our algorithms with the help of these blocks, and we would mark them exactly. What data can prompt you? What data can tell you that the person is about to leave? What is the red flag that tells you that the person is about to leave? Some people people just want to know when people are willing to leave them. It's a sensitive information. Within Sber, we have accumulated a lot of data related to that. We have digitalized all information related to employees. Speaking about personnel outflow models, we have separate models for every segment. Let's imagine you're a technical expert at T department. We have information about how you do your developments, how you do your job, and how fast you are making decisions, how fast you are doing TR and CR. And we have a Jira system deployed for that in the bank. We can take statistics from there. We can use some social demographic factors. We can use some additional characteristics. So depending on the segment, there will be different things that impact your decision to leave the business. So for one segment, these are one red flags and one data. For the other experts, different indicators. So mass job employees, we use Jira to determine whether people are about to leave or not. So we've discussed these disputed points, and now it's a pleasant question. When you understand that the person is about to leave, what are the ways to retain the person? Do you consider whether people are considering other employers? There is statistics on reasons of personnel outflow. It's different depending on the segment and is standard for the market, not only for Sber. Some people don't like their job. Some people don't like their responsibilities. Some people don't want to grow faster. They want to get promoted. Some people don't like relationship within their team. So there's a lot of reasons why people are considering leaving their current place of employment. So what are we doing? We are either offering a promotion or changing the job within the business. So you can change the job completely. For instance, a few years ago, it would be difficult to imagine that Sberbank would work in different markets, but now we have Sber Mobile, and we have Sber a telecom industry, and we have Sber Info that is providing cloud computing. So we have a chance to offer people to change the job to any other area, literally. So we retain people different ways. First of all, it's responsibility of a business partner or functional manager of this person, and he works with this employee face-to-face, and he might retain the person somehow. There's another question. Maybe the wording will not be right, but why are you not using API? And here it says HH or HR. Maybe it's a typo. HH, it's Headhunter. Why are we not using API to collect information from Headhunter? The majority of CVs come to us from different sources, not only from Headhunter. Maybe it's a structured template, a structured layout from Headhunter, but this person was not from Headhunter. We found this person elsewhere. If there was an interface that would help us, if there was an interface that would oblige all candidates to go to Headhunter and we would find everyone on Headhunter, then of course we would do that. But we have a lot of other structured layouts from the market, not only Headhunter. Here I'm saying Headhunter just as an example. And of course, we analyze all layouts that are applicable to us, that are relevant to us. Thank you very much. As far as I see, these are all the questions to you so far. Thank you very much. This was Evgeny Grigoriev.